Every single year, we emit 43 billion tons of CO2 into the air. Climate change is a big problem in the 21st century, with many negative repercussions to our environment. Our team decided to look at one of the sources of climate change itself, carbon dioxide emissions. This, of course, causes global warming and ultimately climate change. This warming causes extreme weather events like tropical storms, wildfires, severe droughts, and heat waves, said Stephanie Omansky in her article, How Do Carbon Emissions Affect the Environment? But how do we relate this to biomimicry? Photosynthesis is the perfect way to solve this problem, since one of the reactants of photosynthesis is carbon dioxide. Along with getting all the necessary substances to do photosynthesis, we can turn the carbon dioxide into a breathable oxygen. In basic terms, we have to perform photosynthesis without an actual plant.
In order to accomplish any artificial system, we first have to narrow down the source of how it happens. When most people think of photosynthesis, they first think of plants. Photosynthesis happens in the chloroplast, an organelle located in the plant cell which has a chemical called chlorophyll. Simplified, the chlorophyll takes apart electrons from the water and puts it in carbon dioxide, producing the products of glucose and oxygen. The problem with this though is that chlorophyll requires a secondary substance to happen. In plants, the secondary substance is the chloroplast. Meanwhile, the chloroplast requires a plant to live in, which would basically just be a plant. So how could we overcome this?
This is where cyanobacteria comes into play. They're typically found in green-blue algae and have a unique mechanic on how they perform photosynthesis. Just like plants, they have chlorophyll, but unlike plants, they have a thylakoid membrane found in their cytoplasm. This helped us think of our solution proposal.
Our main idea is to mimic the function of the thylakoid membrane and replicate the chlorophyll so they are easy to make. You can put this into a machine that intakes carbon dioxide and water with a window at the top letting in sunlight. The top of the machine doesn't look like glass as in the CAD, so we replaced it with a translucent plastic so that it is visible. Then the machine produces oxygen, which is pumped into the air, and glucose is a waste product. The machine will be best placed next to a house with a water pipe attached to any air conditioning, as water is commonly wasted from air conditioners, therefore preventing any wastage of water whilst cleaning the air. This will be presented in CAD form, as we lack resources to come up with a physical solution and lack resources to come up with a real replicate of the thylakoid membrane and chlorophyll.
If one were to try to come up with a physical solution, they would have to find a way to harvest or make thylakoid membrane and research how to create chlorophyll and put it in as well. With this solution being mainstream, this will reduce the amount of carbon dioxide in the atmosphere, and it will leave a lasting future impact on the generations to come that will benefit the environment.